Good morning or good afternoon, geometry students. It's our first video after spring break. I hope all of you guys enjoyed your spring break as much as you could in the middle of a pandemic. We are continuing with circles in this chapter. Today we're going to be talking about inscribed angles and inscribed polygons. So there is a little vocabulary that we're going to start with. So the first thing that we're going to talk about is an inscribed angle. Don't run out of room because I write too big. All right, it says an inscribed angle is an angle whose vertex is on the circle and whose sides each contain chords of the circle. So up until now, we have worked with only central angles. Remember, a central angle was an angle whose vertex was at the center of the circle. An inscribed angle is going to be an angle whose vertex is on the circle. So very big difference. Its vertex is not going to be at the center of the circle. It's going to be on the circle. And then we have what is called an intercepted arc. See if I can fit it in the blank this time. Did a little bit better there. All right, an intercepted arc is the arc that lies in the interior of an inscribed angle and has endpoints on the angle. Here's kind of how I think of it. You see the angle there in pink? It's kind of like, this is just me, but it's kind of like the angle there is giving this circle a hug. And here's the part that it's hugging, and that is the part we call the intercepted arc. So it's hugging the circle. The part that it's hugging is the intercepted arc. So the endpoints of that arc lie on the angle. Hopefully that kind of makes sense. So inscribed angle, the vertex is on the circle. The intercepted arc is the arc that has been intercepted by the inscribed angle. It's being hugged by the inscribed angle, so its endpoints are on the angle. We really need to know those two definitions to be successful in this section. All right, so we have a theorem. So this first theorem, it says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So let's go back and review. Remember a central angle. Remember the vertex is at the center of the circle. Its arc is equal to the angle. So if the angle is 90, the arc is 90. But with an inscribed angle, whose vertex is on the circle, its arc is going to be half of the angle. So if the angle is 90, then the arc is 45. So very different from central angles. All right, so we have to pay attention to that. All right, so example number 1 says find the measure. We're going to start with part A. We're finding the measure of angle T. Okay, so angle T is right here. That is an inscribed angle, and it is intercepting this arc right here, which is 48 degrees. So here's what we just learned. The measure of the angle, so the measure of T is going to be half of its intercepted arc, which is RS. Well, if RS is 48, then half of that is 24 degrees. You know, it hit me a minute ago. I said something about 90 degree and 45 degree, and I'm not sure I said that right. I think I said it the opposite way, and it just hit me. If the arc was 90, then the angle would be 45. So I'm sorry if I confused you on that. It just hit me that I think it came out wrong of my math. Okay, so letter B. Let's see what's going on. Letter B, we're trying to find QR, this right here. Here's the problem. We don't have an inscribed angle that's intercepting that arc, do we? However, could we find QT? Ooh, sorry. We could find QT because there is an angle that's intercepting that arc. Now let's look at this. It says the measure of the angle is half the measure of the arc. But what happens if you don't know the arc, but instead you know the angle? You would do the opposite. You would have to multiply by 2. In other words, here's what I'm saying, that the measure of angle R is half the measure of QT. Here's the problem. We don't know QT, but we do know that angle R is 50 degrees. And so if I want to get QT by itself, what am I going to do? I got to get rid of that half, and that means I'm going to multiply both sides by 2. So I'm going to find out that QT is 100 degrees. All right, so we have 100 degrees right here. Now you might be asking yourself, how is that going to help us? Well, here's what's important to note. You see that point right there? If you see a point right there, that represents the center of a circle. And if that is the center of the circle, what would we call TR? Think about the definitions we learned back in the first section of this chapter. That would be the diameter, because it's a chord that's going through the center of the circle. What does a diameter do to a circle? It cuts it in half. So that means from T past Q over to R would be a total of 180 degrees. If we took a circle, which is 360, and we cut it in half, it would be 180 degrees. And if that has to be 180 degrees total, and we already know that this part in red is 100, that means that the part in green now has to be a leftover amount of 80. And so that's going to answer our question for us, that the measure of arc QR is 80 degrees. Okay, so let's move on to example number 2. So same ideas here. We have a circle, we have a center, we have some inscribed angles, and some intercepted arcs. So let's take a look at what we're trying to find. Letter A, we want to find the arc of AB. So I'm going to put that here in green. Again, we have a problem, right? There's no inscribed angle that's intercepting that arc. So let's see, what could we do? Well, could we find this one in red? Sure, because this is its intercepted arc. All right, now remember we said if we know the angle, how do we get to the arc? Do you remember? It's where we multiply it by 2. We double it. So AD would be 70 degrees. Now remember, this is the center of the circle. That means DB is the diameter. Again, the diameter is going to cut a circle in half. So that means it's going to take the 360 degrees, chop it in 2, that turns it to 180. So this missing piece over here needs to be 180 minus 70, which is going to leave us with 110 degrees, which is going to be our answer for letter A. Now let's look at letter B. We want to find angle D, which is right here in blue, and it is intercepting this arc that's 100 degrees. How do we go from the arc to the angle? It's where we chop it in half. So half of 100 is 50 degrees. All right, so if we're going from the angle to the arc, we're going to multiply by 2. If we're going from the arc to the angle, we're going to do the opposite. We're going to divide by 2. So that might be worth writing down, something for you to remember, okay? All right, example 3, more of practicing this. So let's start with angle BAC. We know the arc. So what we just wrote down, if we know the arc, to get to the angle, we're going to divide by 2. So 60 divided by 2 is 30. All right, this next one, we want the arc, but we know the angle. So to go from the angle to the arc, we're going to multiply by 2. So 70 times 2 is 140 degrees. All right, let's take a look at the next one. We want angle IHJ, and we know the arc. So to go from the arc to the angle, divide by 2. 90 divided by 2 is 45. Next, we want the measure of arc GH, and we know the angle. So to go from the angle to the arc, we're going to multiply by 2. So 20 times 2 is 40. So if you haven't written this down, maybe put this on pause, write that down. That's going to help you. All right, let's keep moving on to example 5. So it says, in the circle to the right, the measure of arc ST is 68. So right here is 68. It says find the measure of angle 1 and the measure of angle 2. So let's look at angle 1. Angle 1 is this angle right here that I've just highlighted in red. Notice that that angle is intercepting the arc that we have a measurement for. So remember we said if we're going to have the arc and we need to get to the angle, we have to divide by 2. So 68 divided by 2 is not 68. Focus, Wingard. It's 34. All right, there's angle 1. Now we want to find angle 2. So let's look at the picture. Angle 2 is right here. Now what do you notice? It is intercepting the exact same arc that angle 1 did. It's intercepting arc ST. So we take that arc measurement of 68 degrees, we divide by 2, and we get 34 degrees. And that brings us to this next theorem. It says if two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc. In other words, look up here. Angle 1 and angle 2 both intercepted the exact same arc. They both intercepted arc ST. Then what did we just find out about their angles? Well, they are congruent. So if two inscribed angles intercept the same arc, then those angles must be congruent. All right, so let's take a look at example number 6. So we have some measurements. Let's look. We have the measure of this angle right here. All right. And we have the measure of this angle right here. Notice that both of them are intercepting this arc. So according to what we just learned, that means that those angles are congruent. That means they're going to be equal to one another. So I have an equation. So I'm going to begin to solve for A. So I'm subtracting 7A from both sides. So now I have A minus 9 equals 1. And when I add 9 to each side, I now get that A equals 10, which is great, but doesn't answer the question. What's the question wanting us to find? The question wants us to find the measurement of ZWY, so the red one. So here's where I'm going to go to the 8A minus 9, and I'm going to plug in the value for A that we just found. 8 times 10 is 80, and 80 minus 9 is 71. So that angle measurement is 71 degrees. All right, we have another theorem. This says the hypotenuse of a right triangle is the diameter of a circle if and only if the triangle is inscribed in the circle. Remember we learned about shapes being inscribed. That means that they are inside of the circle, but specifically what that means is that their vertices have to all be on the circle. So P is on the circle, Q is on the circle, R is on the circle. So as long as all of the vertices are lying on the circle and the shape is inside of the circle, that is called an inscribed figure. So let's go over what this says. It says that if you have a right triangle that's inscribed inside of a circle, then the hypotenuse is also the diameter. So let's look at the picture for example 7. They're asking us to find the measure of z, or what z equals. If we look at the picture, PQ is the diameter. So according to this, if PQ is the diameter, that means this is a right triangle, which guess what? That means that 4z minus 10 must be equal to 90 degrees. So I'm going to start by adding 10 over to the other side. So I get 4z equals 100. And then we're going to divide both sides by 4. And 4 goes into 100 25 times. So we get that z is equal to 25. All right, let's take a look at example number 8. So it says the measure of angle 4 is 7x plus 3. The measure of angle 5 is also 7x plus 3. The measure of angle 1 is 5x. And they don't tell us anything at all about the measure of angle 2. But what they're asking us to find is the measures of angle 1, 2, 4, and 5. So let's take a look at our picture. Well, this is the diameter. So what does that mean for each of those triangles? Well, according to what we just learned, if the diameter is also the hypotenuse, then that means that those are both right angles. Let's take a look at the top triangle because we have measurements for all of those. So we have a 90-degree angle for angle 6, and then we have 7x plus 3 for angle 4, and we have another 7x plus 3 for angle 5, and we know that a triangle has to add up to 180 degrees. Now this is one equation you could use. It's certainly not the only equation you can use, but I'm going to keep going with this. 7x and 7x is 14x. 3 plus 3 plus 90 is 96. And then I'm going to subtract the 96 over to the other side, and that is going to leave us with 84. And 14 divides into 84 evenly, and it gives us 6. So we know that x is 6. So angle 1 is 5x. So 5 times 6 is 30. Now I want to find angle 2. Well, let's look in that triangle. If this is 90 and we just found out this is 30, that's already 120 degrees. What would angle 2 have to be? It would have to be 60 because we would need 60 more degrees to add up to 180. All right, now let's go to angle 4. This one is the 7x plus 3, so 7 times 6 plus 3. 7 times 6 is 42. 42 plus 3 is 45. And angle 5 is also 7x plus 3, which means it's also 45 degrees, and that would make sense because 45 plus 90 adds up to 180. All right, we are almost done. We do have another theorem in this section. It says if a quadrilateral is, again, we're going to use that word inscribed. Remember, inscribed means that all of the vertices are on the circle and the shape itself is inside of the circle. So if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. This takes us back to a word all the way back from chapter 1. Remember, supplementary means that you have two angles that are going to add up to 180 degrees. Okay, so let's take a look at example 9. We already know angle C is 90. We already know angle B is 120. Now we want to find the other two. Okay, well, angle B right here. Remember that word opposite means it's directly across from it and not touching it. Angle C would not be opposite because angle C uses one of the sides that angle B does. Angle E would also not be opposite because it's sharing a side with angle B. But angle D would be opposite. And according to what we just learned, those opposite angles are supplementary. So if this is 120 degrees, then angle D has to be 60 because that's what we would need to add up to 180. All right, then we have angle C, and it would be opposite from angle E. Again, they have to be supplementary. So if angle C is 90 degrees, then angle E also has to be 90 degrees. Those problems are usually pretty easy to solve. Now let's take a look at example 10 because it's similar except there's a variable in the problem. So in the picture, what I see, I already have a pair of opposite angles that I have information about. Angle I and angle G. Those are opposite angles and they both have some sort of measurement in the picture. So I know that angle I, which is 8m, and angle G, which is 10m, have to add up to 180 according to the theorem that we just learned that says that they're going to be supplementary. So when I combine like terms, I get 18m equals 180. And when I divide both sides by 18, I'm going to get that m is 10. So let's skip F right now. I'm going to start with angle I. Angle I is going to be 8 times 10, which is 80. Angle H is going to be 5 times 10, which is 50. Angle G is going to be 10 times 10, which is 100. And then we come to this last angle. There's two ways you can figure it out. Because this is a four-sided figure, it's a quadrilateral, that means all the angles have to add up to 360 degrees. So you could add all of those up and subtract from 360. The other way you could do it is using the theorem we just learned, which says that these angles, because they're opposites, they are going to be supplementary. If we already know that this is 50 degrees, then what would angle F have to be? It would have to be 130 in order to add up to 180. All right, so we have just finished 10.3, and then tomorrow we will work on 10.4. And then on Friday, we will work on some practice together in a Zoom session. So please don't forget about that. I want everybody to meet me on Zoom. Well, I guess in the RenWeb, I put that it was optional. So it is optional, but here's what I would encourage you to do for Friday. I would encourage you to work on the packet prior to my Zoom session at 12 o'clock. I do think that there are some problems on there that some of you are going to have some questions about. So meet me 12 on Friday on Zoom, and let's get some of those things answered. So you need to be trying that packet prior to noon on Friday, okay? And I will talk to you guys in the next video for 10.4 tomorrow.